Alright, just wait for the projector to wake up. So, hello everybody. You've been listening to people talking for most of the day, and you are the survivors. You're the people that made it through. So, first off, just like to say thanks for attending. And as Benny already hinted, this talk is about cloud-based test labs, and specifically how we could go about creating one of those for our own use. So, first off, the obligatory disclaimer. Funny enough, I just speak on my own behalf. But the views and opinions expressed here are those of mine. I have to read that, and nobody else's. So one quick note, if you're taking notes of this, except for the speed bloggers, all the points that I'm making, even though they don't all show up on the slides, they're in the slide notes, so if you wanted to download it afterwards, you'd be able to see all that, so you don't need to furiously write something down. So last year I came here, first BruCON, and it was a brilliant event, and that's why it was really good to be able to come back this year. And I gave a talk, and it was very light-hearted in the sense that I tried to use the analogy of beer and brewing as a way to talk about cloud and cloud providers. But, you know, that trivializes what is obviously an extremely serious topic. So for 2010, I've waved goodbye to the silly stuff in presentations. It trivializes things which clearly are very important because there's lots of big companies doing it. So my pledge to you is that there won't be any gimmicks in this presentation at all, unlike last year. So, yes, it appears I can't keep even my own promises. I'm getting tired of sounding like the cloud security broken record, okay? And I'm certainly tired of the usual conversations about cloud security, and I have to confess that I have been a vocal part of that, and it's talking about all the high-level cloud security issues, because it kind of gets old really fast once you've kind of thought through it yourself and thought, okay, these are my opinions, but you know, you end up getting seen as an expert, which is always a funny word in my book. And because I run a website that happens to have a domain, cloudsecurity.org, you get contacted by a lot of people about cloud security stuff. And some of those people are reporters and they're looking for quotes. And I'm officially at the point where I'm tired of giving quotes now. That sounds, oh, listen to him at the front, tired of giving quotes. But it's you just read the same stuff because the conversation's not moving forward, yeah? At least in the popular IT press. And so therefore I wanted to change the record a bit in terms of what I'm talking about, and instead of talking about some of these high-level issues, is to actually talk about something that you and I can do with cloud computing and with a security theme, of course. So you get quoted, you become the expert source, and I just wanted to say, again, I'm sorry, okay? So I'm just getting some apologies out of the way here because I sat in the speaker's room last year at BruCON, and I said to myself, and I said to a couple of the other guys over there, I really don't feel comfortable giving this presentation because it's all high-level stuff, and at the end of the day, I'm a kind of hands-on guy, pretty technical. And so it's nice to actually find a project that you can put your heart and passion into that, you know, speaks to your kind of technical expressiveness as well. So with that out of the way, a quick comment. There's 3 security people. They're the guys that are in the white outfits. And this is the typical kind of reaction for security people when you talk about cloud. I couldn't get a slide of somebody rolling their eyes, but if I could have done, that would have been there as well, to really get the full... Oh, he's not going to talk about cloud, is he? Why am I making this point? Because what I seem to sense in like the security community at least the people that I know, is that we seem to have gone down the road of saying, right, well, cloud is so badly defined that it just seems like it's old stuff being brought back again. It seems like a marketing exercise. And therefore, we kind of dismiss it in one way to say, well, you know, my company will never use that, or your company will never use that. And it means that we don't actually engage and have a proper thinking and conversation about what cloud security really means. And I'm not going to talk about cloud security in this talk, so I'll be talking about a security use case of cloud. But what I would encourage, and this slide is just an encouragement really, that if your company is talking about doing cloud stuff, don't switch off, don't disengage, or don't just write it all off, because personally I think that will be an untenable position going forward. Get involved. There's Cloud Security Alliance. I'd encourage you to get involved with them, and really kind of think through what you consider the issues are. But one of the things that I found when I'm speaking about this stuff is that people have opinions and they've never really used it, which I think is always dangerous when, like, we're paid to give advice, often to our employers or whatever. So there's this whole thing where just people are criticizing something they've never used. Okay, you use Gmail, so that's software as a service, that's cloud. But in terms of infrastructure as a service, things like spinning up virtual machines, or using online storage, or using sort of slightly more complex things, a lot of people are making opinions about cloud without actually having used it. So yeah, cloud is coming, and I'm not here to convince you to hold the same opinion that I do, which is that I think in the next 5 years, it's a pretty safe bet that we'll all be doing some level of IT with cloud, if we're not already. And therefore, it pays to, as with any technology, and cloud isn't a technology per se, it's a service model, it's important to understand this stuff. For example, when VoIP came out all those years ago, how many people kind of went home to their sort of test lab and said, I'm going to set up a VoIP server and I'm going to try out some of these handsets. I'm going to try and understand, as I go through the process of setting this stuff up, what the security issues actually are. Yeah, because it's easy to read blogs, it's easy to read somebody else's opinion, but you miss that tactile experience, which is kind of ironic when I talk about cloud, because it's very abstract, and tactile and abstract don't normally go together. But and so the question that I would ask, really, all security professionals, I ask it of myself all the time, is what are you doing to keep up? Yeah, and so with cloud, the encouragement I'm just trying to say is, if you dismiss it, you miss a learning opportunity. You don't have to be an expert on everything. Nobody is, but this is really just a small challenge to say, and we'll come to the numbers in a second, but this is just a small challenge to you, really, just to encourage you that, especially if you've got family commitments and other things and you don't have time for doing kind of security research or testing things, Skylab is actually intended for you, because you're me. Because some of the challenges that I have are logistical and time, and I'm trying to create something here which is not just usable by me. It should be something that other people can use too. And so finding the time to do the research and committing yourself and switching priorities sometimes is something you need to do in order to be good at what you do. I mean, and this is everything I say it's me too, So which brings me to a generic point, which is that you have to find your droid. Okay, I'm not talking about the phone. You have to find your droid. So what is the thing? What's the project? What's the passion? What's the thing you're going to work on? And something I'd encourage you, even if you don't consider yourself very technical, or you don't consider yourself to be some kind of security rock star or something, forget all that. It's nonsense. Think about where your passion lies, and try and find that. And we'll be talking about that during the podcasters meetup if you're interested in that. So for me, I wanted to build something with cloud. So I wanted to actually get my hands more dirty, because there's one thing being quoted or writing blog posts and all the rest of it, but there was a mismatch between the amount of signal I was outputting with my mouth and the amount of doing. So I was doing it, but not as much as I wanted to. And so I thought, well, you know, this is a good chance to really get stuck in, come up with a project idea and do something, and hopefully do something that can benefit other people, not just me. So building something seemed like something that would be good to do. Now, let's talk about friction. This is the thing that often, I'll speak for myself, stops me doing things, is friction. So, for example, if I want to test a piece of software and I need a certain setup created, a certain network, I'm going to have to make some decisions about, okay, my free hard disk space is always on the wrong machine. I never have enough RAM in that machine over there, you know, and I'm already running a bunch of VMs, and damn, I need another one. And so the problem is that there's this infrastructure friction, and that is really the bottleneck between you and some of the ideas that you're having, executing on them, certainly for me. So what I wanted to do was try and remove some of that friction so that I could actually go and explore some of these ideas rather than just think of them and think, oh, they seem like good ideas, and not actually execute on them. So being able to execute is like pretty important in life, and I wanted to be able to do that. So so Skylab is like my meta idea. It's my idea that I hope will help other ideas that I've got. So obviously when you give me a presentation, you can't ignore prior art. So in this case, I have to acknowledge that NASA did in fact launch a couple of Skylab satellites, and now I'm going to use a satellite analogy to reference some cloud pieces, because what we've got there is a multiple docking adapter, okay? In the sense of your own cloud, if you had a cloud, you'd want to be able to interface with different cloud providers. You don't want to be married to a single cloud provider. You need something that can talk to different ones, and you don't really want to have to speak a different language or different API each time you want to talk to a cloud provider. Then there's the airlock module, which means that you need some operational security. So you want to make sure that your test lab is truly a test lab and not a torrent sharing site or whatever else it might be. And because cloud is pay-as-you-go, you definitely don't want it to be a torrent sharing site, because then you're paying for all the transmissions. So, and then we've got at the top there's the telescope mount. And if I think about test labs, I'm thinking about visibility. I'm thinking I want to be able to see what's going on. So in my case, a test lab is great for things like testing pen test tools, testing exploit code, and doing forensics as well. And one of the things that I bang on about with the guys that I work with is, you know, that when we test stuff, we need to understand, you know, every action has a reaction. So what is the visible sign of what we're doing? So is it, for example, if you run an exploit against a target, it might be the CPU spikes briefly. And therefore, when you're going to run that attack in the field, first of all, you know, you're probably not going to run that attack against their super busy server that's mission critical, unless it's perhaps the last tool you've got. And then you'll say, okay, I'm taking an informed risk about what I do here. Or you might talk to them and say, is there a quieter time in the day, processing workload-wise? So you need visibility when you're running tests. So you need the ability to be able to see log files in a single place. You need the ability to understand how your various machines are responding to different things. And then there's the actual workshop itself. That's where you do the experiments. And so Skylab is all about being able to do experiments. So one of the startup mantras is that you should fail as fast as you can. Yeah. So and so being able to experiment, trying to be original and do things, means that you're going to fail. And failure, hopefully everybody knows that failure is actually a good thing. It's the path between kind of you and success. So you have to get all the failures out of the way. So Skylab is all about helping you fail quickly, yeah, which is a positive thing. So quick bit about motives, as already indicated. Learning, so you know, having the opportunity to get my teeth into something and learn more about some of the different cloud services. Also getting more practical. You know, I already gave my comment there. Just doing more rather than saying more. That's generally a good thing. My home server died, so a pretty practical thing. Do I go out and buy another home server? You know, talk about it with the wife. The wife's like, And I'm thinking, yeah, it's going to be pretty noisy, and where am I going to put that in the house? And so I thought to myself, well, I don't want to do everything in the cloud, because I do like having some hardware, but I don't need to buy hardware, do I? So in my case, I leased a server, and it's like 50 euros a month, and it's like four CPU, dual core, load of disk space, and it's good. So I won't advertise the hosting provider, but if you want to know, come and ask me afterwards. I wanted to do something that was open source, because when it comes to things like virtualization and cloud, there's a really kind of wacky thing going on as far as you have open source software, but these are all services. And so they have a certain amount of open sourceness about them, but typically that's the API. So you have an API, which they may say they're open sourced, but then there's a black box behind it, and you don't have any idea what's going on there. With projects, if you're going to share a project, unless I'm going to charge you all for it, which I haven't even sold it to you yet, then this should be something that, as a community, we can benefit from, and hopefully, if people like the idea, they can contribute back as well. So I wanted to do something that's open source, because there are a number of times I see security professionals recording videos or writing blog posts about, yeah, you've got VMware, ESX, or whatever. Well, at your company you might have that, and perhaps you run a copy of that at home or whatever. But I'm trying to do something that can appeal to everybody, so I'm not assuming that you've got money to go out and buy some of this stuff. And VMware, just to be fair to them, they do give away server products for free for non-commercial use. But the problem with that is that you're then tied to VMware's way of doing things. And whilst they're incredibly innovative, like there's no question on the virtualization side that they really lead, and they genuinely do innovation. I don't want to tie a project like this to a commercial product. It just doesn't make sense. And it should be free, and you should only be paying what you're using for, in my opinion. So, and then community project. I did a bad mistake, which was when I originally announced this project back in March, I asked for some volunteers and said, if you want to get involved. And then I disappeared off the face of the planet for a few months, which is not a very good way to engage and encourage community. And so, and I think apart from like being slammed with work and all the rest of it, I think part of it was I realized that I actually needed to get this out of my system. I needed to work on this, and I needed to get the first version out. And then it was like, then let people destroy it, rip it up, come up with something better. But just for the kind of the technical, get it out of my system, it was kind of like, yeah, if I make this a community project, then people are going to volunteer for stuff, yeah? And that's really good normally, but if you kind of need to get this out of your system, you find your droid, then maybe you just should put the first one out there and then let people trash it afterwards and come up with something that's way better. So so running it as a community project, I'm partway through developing it, and I'll show you what's there. And when it's finished, I'll put everything out there, and if people can do something with it, that's great, and if they want to contribute, that's brilliant. But obviously I'm hoping to be able to put out an implementation that people can just use. And then as the use cases get explored, people will come back with fixes and hopefully new features. So, where are we? Let's try that. So, bit about me. I'm not going to read it out, apart from to say I'm a proud member of the Eurotrash Security Podcast, and come to the podcasters meet up later. Did I already say that? Yeah. So that's 2 times. So 3 questions for you. And I'm going to ask you to put your hands up for this, please. First one is, do you use cloud storage? So that could be something like Dropbox or Amazon S3. How many people in the room are using some kind of cloud storage? All right, so that's about 1/3, maybe. And then, how many of you have booted a machine in a public cloud? So, for example, gone to Amazon EC2 and booted a virtual machine up. Just 1, 2, 3. So about 10, 12 or 13 people. And then how many people have played with cloud network overlays, or VPNs, as you might want to call them, specifically in the context of cloud? It's always the guy that works for the provider that puts his hand up. So anyway, cool. Okay, thanks for that. So just, I don't know if you'll call that, but there was a third of you that have used cloud storage. There's a dozen of you that have booted a virtual machine in the cloud, and one guy who probably wrote the cloud network overlay. So that's kind of interesting, yeah. Like, we're information security professionals, and obviously we can't. Not everybody can do everything. So don't take this the wrong way. But it's interesting that we're not using it more, yeah. That we're not finding out and kind of walking through the steps of doing this stuff. Perhaps we're not being asked by our employers about it, But I just find it interesting. Every conference I go to, I ask these 3 questions now, and the results in Europe have been consistent, just like this. So anyway, this talk is about wannabe cloud troopers. So I'm trying to get you a little bit engaged in using some cloud services. I'm not sponsored by anybody to do this. I'm not an evangelist or anything. But if I can't twist your arm with some of the material that I'm going to be showing you, I will be giving away seashells as hats, just like in the picture. So, on-demand test labs, what's that all about? I've already described, the situation where you need to be able to spin up a test network. And one use case I already mentioned is target practice. So, I think I've already covered that, really. Assurance testing. So this would be, a new patch comes out. You need to be able to test it. And you don't have a test server handy, or the test server's busy, which is often the case. And you just need to be able to perhaps start up some kind of golden image of one of your devices, and you just need to be able to apply the patch and test it. Or it may be even better than that. You're not patching everything all the time because your operations are more mature than that. And it may be that you're looking at workarounds. So sometimes, workarounds can be effective, but you need to test how effective it is. And so being able to spin up a kind of inflatable test lab when you need it, and then being able to just take the air out of it at the end and say, right, I did what I did, and I don't need that anymore. So another use case is during a pen test. It's quite possible if you're doing any kind of external testing, particularly if you're trying to get on the inside, is that it's quite useful to be able to have like random IP addresses and have those IP addresses for like enough time to send an email, for example, which may include particular attributes such as to exploit the target. So having like an IP that you can just have and then throw away, that's kind of cool. So being able to run a VM for less than an hour and maybe just pay like 10 cents for that, that would be pretty neat. Now you can do that today. I mean, there's nothing about Skylab to say you can't do that. You can do that with any cloud provider that offers that particular virtual machines. And so that's a great way to just dip your toe in. And so anyway, what's your use case? I mean, what are the situations when you would really want a test lab? There must be some. There must be some projects that you're working on, or there must be some stuff you do at work where it would be really great to have a test lab. And so it's those use cases. And my use cases I just showed you, and that's where I'm coming from. But probably for somebody else, it might, your requirements might be a bit different. But I've tried to come up with a fairly generic one. One comment about cloud and cloud services specifically is it's a commodity. And so therefore, for it to be a commodity and to get the price point that you do for paying for cloud stuff, that means it has certain attributes about it. And so you're getting x86 chipset. There may be clouds that offer different chipsets, but I'm not aware of them. There is a GPU cloud, but from what I can tell, you have to pay a monthly fee before you can use that one, which doesn't seem very cloud-like to me. Anyway, so think of cloud as a commodity. So whether it's storage, whether it's compute, whether it's network, it's a commodity. And so you have to think about it as a throwaway thing, kind of. Another way is to think of it as disposable. So you only use what you need when you need it. So the context of this presentation is about infrastructure as a service. And there's 3 layers, and I talked about them last year. You have at the top layer, you have software as a service. And it's just a way to think about, conceptualize these things. Software as a service, so Gmail or Salesforce. And then you have platform as a service. So for those of you that have heard of things like Google App Engine, and VMware, I think, are working on, with their SpringSource acquisition, I think they're looking at having a platform as a service. And then there's infrastructure as a service. And so the platform is aimed at developers, plugging together kind of higher level APIs that are focused on business transactions of some kind. And then infrastructure as a service is your networks, it's your tubes, and it's your machines, and it's your storage. So that's what we're talking about here, and that's the context of Skylab. So just to talk briefly about the design, there were some design principles, hit some common use cases I've already described. It should be on demand, yeah? I don't want to have hardware sitting around, I just want to be able to use the thing when I need it. It should be infrastructure as code, which is what all the cool San Francisco kids are talking about. Infrastructure as code is this idea that you can describe a virtual data center in a configuration file, for example. So you can say, my data center is composed of these networks that I've listed with these IP ranges, and it has on this network A, it has these virtual machines that are running these type of operating systems, and those virtual machines are either DHCP or they have fixed IPs. And so through a configuration file, you should really be able to say, or through an API call, you should really be able to kind of describe what kind of virtual infrastructure you're looking for. And that's cool, because if you had that, then I can share my network with you in the sense of my network design, my test lab design. I can share that with you, and if you've got the same code as I have, you can invoke all those. You can invoke that. You can inflate that test lab. It's yours because you're using perhaps the same public cloud providers that I'm using. Yeah, but it's not married to a specific provider, so it's got to be provider agnostic. On the subject of providers, though, when it comes to infrastructure as a service, there's a guy called Guy Rosen who measures and kind of tracks the number of cloud instances that are being spun up at different cloud providers. And when you look at his charts that he comes up with, it's like Amazon is the big gorilla. There's others, there's Rackspace and so on, but in terms of their market share, it's just like Amazon's this. And so inevitably, because they're so dominant, then they're the first one that I'm using for this. But I'll show you how the technology plugs into other cloud providers. Cost conscious. As I get older, I get more cost conscious. So I don't want to waste money. I don't want to, as I say, buy excess. I don't want to sink capital cost in for sure. And this cost conscious, this is, you could imagine your business leaders saying this. They don't want to spend what they don't have to. They don't want idle hardware lying around. And also hardware reuse, like, not everybody wants to have everything in the cloud, and that's probably not what you want. I don't think, put it this way, when I was thinking, how am I going to do this, I thought, yeah, I need like one server. You don't have to have a server, but you're just thinking, well, I don't want to run a bunch of VMs that I'm paying for 24/7 on a cloud provider, public cloud provider. I'd still want a base system where I can run some stuff on mine, and then when I don't have any capacity left, I want to be able to use their, I want to be able to use their services, but I want to be able to do it transparently. Like starting up a VM on my server should be the same as starting up a VM in, say, the Amazon cloud. Yeah. And then some other design principles. In terms of your servers, one or more servers that you may already own, that you might say, okay, this is my test lab, then you should be able to run any kind of hypervisor. So there's pros and cons to all of these, but let's not get religious. We need the flexibility, because someone might say, test this VM appliance, and it's in VMware format. Sure, you can do certain things with converting machine images, but it'd be kind of cool if you've already got like VMware deployed. You kind of want to be able to just interact with that. So the technology that we're going to use for our cloud platform has to be able to talk to, say, VMware infrastructure, has to be able to be agnostic about whether you're using Xen or KVM. KVM is the Linux kernel virtualization machine. And then the security test lab, I've already mentioned some of the features. So it should have visibility. I should be able to have certain things, like I always need a network sniffer on just about everything. So I should have a way to, spinning up virtual machines is nice, but then the question comes, so what? Yeah, what are you going to do with it? You have to be able to link them together, and you have to be able to configure them very quickly to be what you want them to be. You have to give them a personality. You have to install some software. You have to configure certain things. And so for a security test lab, there's certain things that you would want probably on every machine, yeah? Or you would definitely want on certain machines but not other machines. So there's this notion of configuration management, which is what enterprises struggle with. You know, you have masses of machines and you need to be able to deploy very quickly the configuration that you need. So if you're starting up 10 machines in a public cloud, you're either going to pick a generic, say, Linux image, and then you're going to need to go in and configure that, or you're going to have created the perfect image and then you upload it to the cloud provider, and then you spin up 10 copies of those. Personally, I don't like sending VMs all around the place. It takes time and it's hassle, and I don't like using your VMs. I'm sorry, but from a security point of view, like, this practice of sharing VMs is really good from the point of view of just getting experience with something. Yeah, so that's, for me, is a great use case. So I'm willing to download your VM and try and isolate it so that I can perhaps get experience with your software project or whatever. But I don't want to encourage people to share whole VMs, yeah? Because that's just asking for trouble. You know, why do we need to do that? Can't we express what should be in a machine in a text file? Yeah, so configuration management is about having recipes and having ways to spin up a machine and quickly configure it so that within, you know, a minute of it booting, it's how you want it to be. So freedom, open source, I'll talk about that in a second. And pragmatic. I'm as tempted as I am, because I'm a geek, there's no benefit in me reinventing wheels that already exist. Generally when people reinvent wheels, it's a great learning exercise, so there's value in that. But most of the time, unless they're coming from a very different discipline or background, the wheel's going to look pretty much the same, and it's just going to have a different set of bugs. So I'm trying to use components that, and this is all based on other people's stuff. You know, I've got to be really clear on this. I'm not inventing software here. There's some glue that I'm applying. You know, it's probably the best way to describe it. But I want to be able to use components, and we've already talked about the hypervisor. That's obviously one component. You won't catch me coding one of those. And it should be scriptable. And what do we know about scriptable? It's fun. Do you like scripting? Anybody? Yeah, geeks in the room. So, to make this happen, you need a cloud platform. And you can't just go to the supermarket and buy a cloud platform. What is platform? Because I know that until someone explained it to me once, I just thought it was a marketing term. Whilst it is a useful marketing term, I can see that. You know, platform really means that you have an environment, let's say, where you can you have a set of typically integrated services, and it means that other people can kind of code for that platform. So then you have this ecosystem of products and services around it. So you need a cloud platform in order to do, like, spinning up a hypervisor is easy, yeah? On your command line, you can just type kvm, blah, blah, blah. But then you need to configure it, and you need to spin up multiple, and you need to have multiple, say, groups of machines that would belong on different test networks, and you need to do your networking and everything. So there's all this stuff that's involved in creating a virtual data center. And so you need software that will do that. That's the cloud platform. That is the meat of any of what I'm showing you here. And one of the things about the cloud platforms, and it took me quite a lot of research to find one that was right, is that they have varying levels of openness. And I'm not standing here saying, you know, all software has to be open, and, you know, we should, you know, burn developers' houses that get paid for writing software. Because if we did that, we'd miss a lot of good software. And a lot of bad software too. So someone from there's a new cloud platform, which I'm not actually using right now because it's like brand new, and they're just bringing out version 1. It's called OpenStack. And one of their guys wrote a brilliant blog post where he went through the 5 layers of open source when it pertains to you know, software projects. And with cloud, this is again really important. So you understand it. Like the lowest is like, here's the API, everything else is a black box. But a company may open source the core of the product and then sell enterprise features, you know, obviously commercially. The other one is they might open source the project itself, in which case that could just be a tar file. Right, here's a tar file. So you'll see that with Linux driver, Linux vendors, well, sorry, vendors of like graphics cards and so on. They typically will throw a tarball over the fence and go, it's yours, get on with it. Is that really open source? Yes, it's open source code, but it's not an open source project. So the development process, that's when you can see things like bug databases like Track or Redmine, and you can see roadmaps and stuff like that. That's the open source development. And so then finally, the most extreme form of open source is where you have a group of people that perhaps they form a board or something, or a project team, and there's a decision-making process, and so you can get involved in that. You could say, right, I want to join that group, and you get people to vote you onto it and stuff. So this is really important, because whatever software you're going to end up using for your cloud platform, it's important to understand at what level this is, because then you can understand how much you're going to be able to change the platform, like if it doesn't do what you need, how much support it's going to have, obviously community involvement, etc., etc. So I just mentioned this because I found this a really useful way to think about open source software in general, but also in particular cloud platforms. So I will skip all the, I looked at this, I looked at that, then I was, it doesn't do this or it doesn't do that. And I'm going to ask you, how many people have heard of Open Nebula? That's a couple of people, right? So here I am, cloud security expert, and I do say that firmly tongue-in-cheek. And I'd never heard of Open Nebula, but it's like an open source cloud platform. So it was like discovery of the year for me. It was a slap my head moment, really. And it's a project run out of Spain from one of the universities, and these guys have just been building a cloud platform which can be used in 3 deployment scenarios. You can use it as a private cloud, so running it on your own servers. You can run it hybrid, which means that you run it on your own servers, but you can cloud burst, meaning you can invoke services at public cloud providers. Or you can run it as, sorry, that was hybrid. And then you've got public, which is where you run your own cloud and you sell that service. So I could set up an Open Nebula instance on, say, if I had 20 servers, let's just say, and set up a small Open Nebula setup, and then there's an API which you could use, and I haven't seen the billing module, but I think there is a billing feature, but I'm not interested in that. But I'd be able to then charge you, do proper chargeback for your use of services. So you can actually run it like that. But what's cool about having an API that other people can use is that your test labs are no longer just your test labs. They're test labs that if you want other team members or project members or friends or whatever, you can give them access to individual hosts, of course, but you can actually give them access to the cloud platform, which means that they could create their own test networks, for example. So just briefly, like the private cloud with Open Nebula, there's a front end, and then there's cluster nodes. And when I say cluster, you might be the danger of saying the word cluster is that for many people that kind of starts getting them close to grid. And grid is, and Thomas is going to be talking in the Lightning talks about his use of EC2, and he's using it it's a great use case. It's a classic use case of cloud, which is, you've got a load of compute tasks that need to be done. So you spin up a bunch of virtual machines at a cloud provider, you parcel up the work, chop it up, and then you just give it to those, and you say, right, go ahead and do that. And so from a security point of view, like use case, that could be like password cracking, all that. But that's all perfect like use case, and you're doing a time money trade-off. Yeah, so you're saying, I'm going to spin up a bunch of VMs that are going to cost me X per hour to run, and if I want the job to run faster, I'm going to start up more VMs. Yeah, so that's the concept there. And as far as these cluster nodes, you can use them how you want. I mean, it's just look at it as a resource, a compute resource. So you can start up VMs as many as you need, whatever else. And so the front end controls that. So in my case, I don't have multiple servers. I have this single lease server. So I'm running the front end. The single server is acting as a front end and a cluster node. And that's fine. You can run it like that. And my goal is that I just want the one, I did my maths and figured out how much RAM I need on that server for my usual stuff. And then I'm like, okay, when I need to go over that, I'm just going to use public cloud services. And that's what's supported. I've already mentioned you can do this hybrid thing. It interfaces with Amazon, also with a company called Elastic Hosts, and then through another mechanism, the Red Hat's Delta Cloud. It interfaces with Amazon again, GoGrid, Rackspace, Red Hat, Rimu hosting, Terramark, and vCloud coming soon. And you can see the features, you can create instances, start and stop instances, blah, blah, blah. Why is this interesting? Why am I telling you about it? I'm telling you because from a single command line, you can type a command which will start up a virtual machine and manage the machine, so start up, shut it down, reboot it, whatever, through any of those providers, through using a combination of OpenNebula and Red Hat's Delta Cloud. So once you've got that, once you set up that, then your command to spin up a VM based on a template file is going to go off to one of those providers, but the command to actually instantiate is the same. That's kind of cool. Like one command, I can start up a VM anywhere, or I can start up many VMs. So, so Red Hat have kind of created this Delta Cloud to kind of act as a kind of cloud broker, but it's software you run. Yeah, so I will have on my single server a virtual machine that's going to be running Red Hat stuff, and Delta Cloud. So my OpenNebula instance will kind of interface with this VM in order to be able to spawn instances elsewhere. One thing to mention, since we are talking about pay-as-you-go, is don't forget to turn the stuff off. I've made the mistake a few times now, and funny enough, the cloud providers are not falling over themselves to implement things like notifications. Oh, by the way, you've been running those 500 Amazon instances for 3 days now. So you don't get it, and you look at your monthly bill and you're like, oh, yeah, I forgot. So it hasn't been mega money, but it's been kind of annoying. So one of the features is just going to be a real simple script to remind you that you're still paying for stuff, because you just forget about it. I tell you, it's out there, and it's started up, and you got distracted, and you never turned it off. So just worth bearing in mind. And then the other thing is, just because we're talking about test networks, there's certain things you can't do according to the terms of service at public cloud providers. So for example, if you read Amazon's one, you're not meant to intentionally put malware onto a system there. Yeah. So if you were trying to create a malware test lab for analyzing malware, then technically you'd probably need to I think technically you shouldn't be able to do it according to the terms of service. So that's one thing with cloud providers in general, and I monitor all the terms of service for all the major cloud providers, and they change these things really regularly, and they don't often email you. They only email you if it's a particularly significant change. But the funniest change is when Google changed their terms of service, obviously didn't mention it, and said that you weren't allowed to use Google App Engine for anything to do with nuclear weapons development. Okay, cross that off my list then. So let's briefly talk about cloud networking, because starting up a bunch of VMs, that's nice. You can get them all like robots doing the same thing, but in this case we need to simulate networks, so we need a way to string them together. So the first thing to bear in mind is that if we take Amazon as a really great example, you only have one network interface card on an Amazon VM, yeah? So you have to use Amazon security groups to do anything. For example, to have a multi-tier web setup, you'd have to use Amazon security groups as a way to kind of associate traffic flows with different systems. Well, that's not very cool, because we just want to use regular routing, really, or routing for my American friends. And the thing is that the routing options are pretty limited, and so therefore that puts a bit of a kibosh on being able to set up simulated networks. So we need a way around that. Also, just to mention it, they have basic firewalls set up. Amazon by default, when you spin up a VM, doesn't allow any traffic. You have to tell it, I want SSH or whatever else. So overlay networks, this is Wikipedia, and because obviously they know what they are. And it's a computer network which runs on top of another computer network. So it's a VPN, it's one way to talk about it. So we need essentially a VPN infrastructure. Now, on the subject of VPN, the cloud providers are obviously aware that people like to be able to connect there. Some people want to connect their enterprises perhaps up to a public cloud, and so they provide the virtual private cloud, which basically is they run a VPN gateway on their cloud, and you're able to access that. If you set up the necessary stuff on your side, you have a site-to-site VPN, Site-to-site VPN is preferable to having all the virtual machines that you spin up, like phone home and join like an open VPN, with an open VPN connection, and have all these like peers on there. It's much better generally for replicating networks. Most networks aren't made up of a bunch of endpoints that VPN back. That limits some of your networking opportunities. So with site-to-site VPN, you don't have some of those issues. So that's pretty neat. They've made that available in all their data centers. And so part of Skylab is to be able to VPN site-to-site over to there. And there's great software, free software that will do that for you. And so that's a component. Now obviously Amazon is one big cloud provider, and not all the providers offer that. There's a commercial solution that I'm only mentioning because they build it on a lot of open source software. They did obviously some magic, but it's open source. And these guys are really good. And so there's this VPN cube, so you can run basically a virtual machine that's acting as a VPN gateway at multiple clouds. And so you can connect multiple clouds together and have your network overlay, which is kind of neat. Now, I'm not using VPN cubes as part of Skylab, but I thought I'd include it for completeness, just in case you need it for other reasons. Then another essential feature is the config management. I've already mentioned that you need to be able to deploy and then quickly customize machines. Here's an example, and there's different config management tools out there, and it can get a bit religious, actually, from reading some of the mailing lists. Some of you may be familiar with CF Engine. That was really one of the first big successful configuration management tools. And then there's other ones like Puppet and Chef, great names. And this is an example of once you have some recipes, which, for example, might install a piece of software or might edit a configuration file, you can basically do things like this. You can just describe in a text file, okay, I'm going to have a role of when I have a web server, it's going to have these different features, these different software installed. I'm going to set these ports and all this kind of stuff. Now, the reason why I'm talking about specifically Chef is that they've done a really good job on the community side of things. Opscode is the company that writes Chef, just to be clear. And so they've got all these people that have contributed Chef recipes. And it runs on Ruby, so you've got to have Ruby on the endpoint, but you can have that kind of in your image just as a default thing. So it's not suitable for very customized virtual machines where, for example, Ruby doesn't run, or you don't want Ruby to run. But for my needs, for simulating like enterprise networks, that's fine. So I was going to show you something, but interestingly enough, can't actually get to my server from here, which is kind of annoying. And all I was going to show you, and this would probably have the desired effect, is that was how you use OpenNebula to spin up a bunch of instances. And I showed some people last night, and they had the open mouth thing, because you just literally type, I want one VM, it's one VM create, and then the machine type you want to deploy, and you can just keep doing that. And so you can write a little script, 3-line shell script that starts up 75 instances, and it's just the same as if you start up the local VM that's running on your own hardware. So anyway, I'll have to post a video or something on that. I don't know why I'm unable to get to the server. But so to do, just to say, so I've got OpenNebula installed, and I thought that was going to be a walk in the park, setting it up and having the connections to the cloud providers, but it wasn't. And so I've ended up learning quite a bit about OpenNebula. I like it, and it's just one of those things when you're dealing with, the challenge with this project is there's a lot of moving parts. Yeah, we're talking about OpenNebula, which is a huge project. We're talking about setting up virtual private networks, and we're talking about Chef for configuration management. And so it's like a big deal to do in the sense of like gluing it all together and getting things set up right. But my goal is to make it so that it's basically a recipe, so that someone can take it and they can just run like a script, and boom, it's all set up and they can just use it. Someone used the analogy of, like a live CD. And I said, yeah, I guess that would be it. So you should be able to, whether it's physically like putting a live CD or a USB, you should be able to put that in, and it should be able to pull down all the the sources, compile everything, get it configured right, and then just ask you, right, give me your cloud keys, which are the keys that you require when you make API calls, and just, you know, there you go, you've got a test network. And the point is that we'll be able to share, like, my goal is to come up with like a JSON file formatted configuration file. So that's how we'd describe, like, this is the network I want, this is the host that will be on the network, this is the IP ranges. And so again, we'd be able to share JSON files. And so if you have a particular setup and you say, oh, this is my cool setup for XYZ, and if you're using public machine images, so for example at Amazon there's a repository of machine images, and if you're using one of those, then you can just include the instance identifier, and so then I can boot that instance too. Yeah. So it's one of the brilliant things about cloud is not having to build loads of instances yourself, like virtual machines rather, because they often have a big repository. You might say, well, I don't want to trust my cloud provider's virtual machines. How can I trust their templates? You know, but often they're contributed by, for example, the Ubuntu images all contributed by Canonical. So you just have to look for the ones that have been contributed by Canonical. Of course, it's easy to slip up and boot some rogue one, and that's been demoed at other security conferences. But if you look carefully, and also if you script it, you don't have any issues. So building the visibility VM, that's basically going to be Splunk and Nagios, and when the virtual machines get booted up, they will be auto-configured to have the Nagios client and to have to send everything to the Splunk server, in addition to some of the other bits like having the sniffers automatically installed. And I'm probably going to set something up so, because like with TCP dump you can do remote sniffing, and so you can have like sniffer sensors, so you can set up a sniffer on all those different ones and have the traffic coming back to, say, a single machine, which can be kind of interesting for different use cases. And then need to build, the tedious part is frankly going to be building a bunch of VMs and writing the chef scripts to configure them. That's just going to be tedious, but for example, I need to be able to run, you know, Windows 2008 server, and you can do that. You know, you can do that on a public cloud. You can do that on your own machine using anything, but OpenNebula supports that too. So I need to be able to do config management for Windows, which certainly isn't my strong suit. And at the moment, the best option seems to be PowerShell, because even though Chef does have Windows support, it's pretty limited. And I hear that they're going to be doing more, but we'll see what they do over time. But for now, it might just be a case of doing some PowerShell scripts for that. And then the final part is really just this script that will generate the JSON file if you don't want to just hand edit it yourself. And so it would just ask you, right, what kind of test lab do you want? You know, what networks do you want? What VMs do you want? And you just take that script and run it, and that's got all the OpenNebula commands for starting everything up and making sure everything's configured, and that would trigger all the Chef stuff, so that we've reduced all the friction. We've just got text files, and all the magic is in the infrastructure behind it. So that's really what needs to be done. And then futures. Obviously, I've just said some futures because those are the things that I'd still need to do, but it's already multi-provider, so I can actually cross that off the list. It's a bit of a limitation just having x86 targets. You can, of course, run emulations. There's nothing to stop you doing that, but obviously not all platforms have emulators available. So it's just one of the limitations. You know, it's commodity, cloud's a commodity, but on your own server, you know, you can set things up a bit more flexibly than, for example, running a VM within a VM where it's even supported is not always great. But since you've got one hardware platform that's physical, then you've got more scope for different platform support. VMware support. So I mentioned OpenNebula does have the ability to interface directly with that, and I'm going to have to make sure I focus some time on that and make that again transparent. So, you know, you need a way to say, yeah, I want to use that VMware VM farm in the configuration file, but that should be, it should just be a hint rather than having to put any other information in there, and so it should handle all the stuff for that. Yeah, I think the rest is pretty much covered. So that's my website, and fortunately I included a hidden URL there. So If you're really clever, you'll be able to find it. And that's where I'm going to be posting updates about the project. So I'd say I'm about 40 or 50% done. I'm hoping that in the next couple of months I can be completely done. It's big, and that's the thing. It's a real learning curve. Like, this is definitely a learning curve. But I'm trying to make it so it's good for everybody. So making it simple is the hard part, which is typical in engineering. So yeah, credits for the pictures, stormtroopers, Stefan, and to all the pieces of software that I'm using, because this is like definitely. This couldn't exist. Like, if you go back a few years, you couldn't do this, and that's what, just to end, that's what I find so exciting, is that a few years ago there is no way you could even implement something like this. Yeah. So that's what's cool about this. This is something new, and it's something which you simply couldn't do before. Yeah. Now you can, and that opens up so many doors, and hopefully it will allow us to, explore the ideas that we're coming up with, which we would normally say, can't do that now because the test lab's busy. Yeah. So, any questions? No cloud? No, no cloudy questions? Well, last year Didier asked me a good question. It wasn't related to my presentation, and he asked me what is the in Belgium when they pour beer, since the presentation was heavily intoxicated with beer themes, do they put a head on the beer or not? Because for example, if you're from England, you're likely to get in the barman's likely to get in a fight if he puts a head on a beer. Whereas in Hungary, which is where I live, they put a big head on the beer, and so I thought, well, probably not been to enough pubs here yet to really know. And it turns out there's no standards, so it was a trick question.
Okay, thank you, Greg.
Cheers.
Okay.